All right, so we're gonna wrap up. We're gonna wrap up 9.2 today. We left off last time right here. So in the Benford's law and fraud example from the previous lesson, we tested the claim that about 30.1% of the numbers in financial records begin with the digit 1. Suppose that P is 0.25. That is 25% of all financial records at this company begins with the digit 1. When alpha, that's your significance level, is 0.05, the power of the test is this. Interpret this value. So what does the 0.58 mean? Well, it means that given that the true population of expenses that start with the digit 1 is P equals 0.25, there is a 0.58 probability that there will be convincing evidence that P is not 0.301, which is what our alternative hypothesis was. So let's go ahead and write that in. So given that the true proportion of expenses that start with the digit 1 is P equals 0.25. There is a let me clean that up. There is a 0.58 probability that there will be convincing evidence that P is not 0.301 or 30.1%. And so this is basically what our alternative hypothesis was. And that's how you interpret the power of a test. All right, moving forward, part B says, how can AJL and Associates increase the power of their test? Well, you could increase sample size. So you can increase sample size. But the downfall to that is whenever you increase sample size, it's going to take more time and it's going to cost more money. So just keep that in mind. So it costs more money and it takes more time. And there may be other, so etc. There may be other pitfalls to that. Okay. All right. Another thing you can do to increase the power is increase the significance level. So you could increase your alpha or significance level. Okay. But the downside to doing that is you're more likely to needlessly investigate. So you're more likely to needlessly investigate. Okay, it's supposed to be a T. All right, and then another thing that you can do to increase the power is maybe use a stratified sample. So use a stratified sample. Okay, and what this does is it decreases variability. But the downside to that, again, similar to increasing sample size, it's just going to take more time, cost more money. So more time, more money, and so forth. All right. So for part C, and this is actually the last part of 9.2, it says, for what values of P would the power of the test be greater than 0.58, assuming everything else stayed the same? Well, you need to have larger difference between your null and alternative values because it's easier to detect. So you need to have a larger difference between the null and the alternative values because that's easier to detect. Okay. So for example, our null was 0.301, and so we want to have a distance that's greater than our alpha. So our alpha was 0.05. So let's say we go up by 0.051 and we go below by 0.051. And the 0.051 is just so that we're greater than the alpha. Let me clean this up. Okay, so when you do that, you then get this, the upper bound to be 0.352 and your lower to be 0.25. So you're just subtracting, well, from the 0.301 you subtract this and you get this value, and from 0.301 you're going to add this value and you get this value. So any value of P less than 0.25 and P greater than 0.352 is farther away and increases power. And that wraps up 9.2. So we're ending 9.2 here. The next video will start 9.3.